Absolutely. So, hi everyone. Hope everyone can hear me right now. My name is Billy Korando. I'm a developer advocate with IBM, and Kripa is bring up my presentation I kind of pre-recorded on, as you can see, how to upgrade the automated test with JUnit 5. So I'll be here in the Q&A. So if you have any questions during the presentation, definitely feel free to reach out and ask me. I'll be more than happy to answer any questions. Also, I'll be posting in the Q&A. I put together a quick lab so you can actually kind of get some hands-on experience here with using JUnit 5. So you can go to that quick lab. If you're not signed up with our skills network, you can sign up with that, but then it can kind of get you some hands-on experience with working with JUnit 5 as well. But like I said, I'm here for any questions, so don't hesitate to ask. I'm not hearing anything. I don't know if that's the case. Okay, cool. Hello, my name is Billy Korando. I'm a developer advocate with IBM, and today we're going to be talking about how we can upgrade our automated testing with JUnit 5. So before we get into how JUnit 5 can help with automated testing, let's just quickly review why we should consider writing automated tests. After all, writing a quality automated testing suite will take a considerable amount of time and effort to both write the test and maintain them. So why should we be doing this beyond just some sort of vague best practices reasoning? Well, modern development all requires speed to production. Indeed, it's been the case for a long time. But when developers push their code, it should be built and then pushed to production, and this process should be automated. But no organization is just going to accept building code and push into production without any sort of validation, so we need to have our testing process also be automated. The book Continuous Delivery by Jez Humble and David Farley profoundly changed how I view software development. Before becoming a developer advocate, worked as a developer and consultant with many different organizations, and getting to production was often a painful and difficult and time-consuming process. This was often the case because we relied upon manual processes to complete these tasks from deploying, but of course when it comes to testing. And manual processes can, along being slow, can be error-prone and difficult to replicate. So two key features of automating is that automation is auditable. Scripting out your deployment process and of course writing out your automated test, you can review what is being tested, and then the test reports and logging and the system responses from running these tests or automation scripts can then also be reviewed to make sure all the tasks are being completed, all the tests are being run, and seeing what is actually being responded to from the system. Automation is also repeatable. Computers are really good at performing repetitive tasks, much better than humans. Humans may forget to run a task, run them out of order, or run them with incorrect information, which can cause an issue to fail, which then can make it very difficult to trace down and find out what is going on. Could it be the code that is wrong? Could it be something wrong in the build process? So by automating these tasks out, we save a lot of time and also have a lot more confidence in deploying code to production. But this can also ask the question or raise the question of how much testing is enough. It's sometimes hotly debated, how much code coverage do you go for? 50%, 75%, 90%, 100%. It doesn't really make much sense. What really should be the case, what you should be asking yourself is, are you confident enough to push this code to production without any sort of human intervention as far as testing is concerned? So that's going to vary from application to application and of course across organizations. And an internal application that is infrequently used and non-critical is going to have a much lower threshold of going to production as far as testing is concerned when compared to an external application that is heavily used and is performing business critical functions. So with that said, let's start focusing on migrating to JUnit 5 assuming you may already have an automated test suite written, you want to be able to still reuse this code and test that you've written and spent a lot of time working on, but maybe start taking advantage of JUnit 5. Luckily, the JUnit 5 team has done a great job on handling the migration aspect. So first, to be able to start taking advantage of JUnit 5, you have to be using at least JUnit 8 or Java 8, and then be using Gradle 4.6 or later, and then Surefire and Failsafe 2.22 or later. These are pretty old versions now, about 1 or 2 years old, and of course Java 8 came out in in 2014, so hopefully you're kind of on some of these most recent versions. If not, you should also upgrade to them as well for both the performance and security reasons. So if you already also have a large test suite written in JUnit 3 and 4, you want to be able to, again, continue to run those tests, maybe as you work on moving over to JUnit 5. And luckily, there is great migration support for JUnit 3. I believe it's JUnit 3.8 or later, and then all of JUnit 4. And JUnit 3.8 came out in the early 2000s, so hopefully you're not having anything older than that running right now. Also, if you want to use JUnit 5, but your organization is using a bunch of rules, you can start writing JUnit 5 tests and also still use JUnit 4 rules with the migration support that the JUnit 5 team offers. So to be able to run JUnit 3 and 4 tests along with JUnit 5 tests, you will need to import the org JUnit Vintage engine dependency into your project. You will also then need to use the org JUnit Vintage JUnit Jupyter migration support if you want to run JUnit 4 rules in actual JUnit 5 tests. So for the first one, you would still be running these JUnit 3 and 4 rules without any changes whatsoever. The JUnit Jupyter migration support is only if you want to use JUnit 4 rules while writing JUnit 5 tests. And so if you were to do that in a JUnit 5 test class, you would add the annotation enable rule migration support and then bring in your rule. Again, that's only for if you're using JUnit 5 tests. If you're writing JUnit 4 tests, then you wouldn't need to use the enable rule migration support. So JUnit 5 is also compatible with pretty much all the popular test libraries. AssertJ and a Hamcrest, if you're using those assertions, which I would generally recommend over the core JUnit 5 assertions, totally compatible. Even older versions are compatible with it, so you wouldn't even need to use a recent version of these libraries. Mockito and test containers are also compatible, and really most popular testing libraries should be compatible with JUnit 5. JUnit 5 was released back in 2017, so most of these libraries have had time now to migrate to support JUnit 5. So there are some language changes if you want to start writing in JUnit 5. So to mark a test as a JUnit 5 test, you would use the org JUnit Jupyter API test annotation. If you were to use the JUnit 5 assertions, they are located under the org JUnit Jupyter API assertions package instead of the org JUnit assert package. Ignore has been replaced with disable, and we'll get into some of the changes along with that. Run with, rule, class rule have all been rolled into the new extensions model, and again we'll cover that a little bit later. Before class and before, and after class and after have been replaced respectively with before all and before each, and after each. And those have the exact same functionality, just the annotations are a bit more clear in their intent than they were before. So you can maybe move to JUnit 5 easy enough, but why would you want to? So let's kind of cover how JUnit 5 kind of improves upon some of the existing capabilities that came in JUnit 4, and then a little bit later we'll kind of get into some of the new areas that it has addressed, as well as some really new creative ways you can write tests in JUnit 5. But first, let's cover some of the ways JUnit 5 improves over just JUnit 4. So we're going to look at assert all, exception handling, extensions model, the parameterized test, repeat a test, dependency injection, and conditional enabling and disabling of test. For assert all, sometimes you have to write a test and there's going to be multiple assertions in it, and then sometimes those tests fail. And there can be this annoying and frustrating cycle you can get into where you fix one assertion, run the test again, and you had to fix the next assertion, and you had to do this process 3, 4, maybe plus times, however many assertions you may have in a test. And that can be annoying, particularly maybe if it's a longer running test or there's just a bunch of tests you have that have multiple assertions within it. So to address this, there is now the new assert all assertion that can wrap multiple assertions within it, and then it will capture all the assertion failures within it and then send them up in a single test report. So if all these assertions in this test case were to fail, then it would say there were 4 failures within this test case instead of just 1, and then having to rerun it again to find the second assertion failure. For exception handling, typically a lot of times when writing JUnit 4 tests that are testing for exceptions, you would use test and then expected exception next in parentheses next to the test annotation. Instead, there is now the assert throws that will then return the exceptions that's being thrown, which can then be further inspected. This is much cleaner and also much more consistent, whereas before with the expected, you would have the assertion for the test kind of outside where the test is being declared. Now it'll all be consistently inside the actual test case, and if you were to need to inspect the exception, like to see if there was a message within it that is correct for what you're expecting, it's a much easier to do that instead of having to do a try, catch, and then rethrowing of that exception. Multiple extensions can be declared within the same test class, whereas before with run with you could only have a single run with. Here we have this example of multiple extensions being declared for the same class, in this case using Spring JUnit config and then also the data.jpa test attached both to this test case. When declaring extensions like this, the order in which they're declared within the test class, like so the physical line numbers they're in, is the order that they will be executed in if there is for some reason you care about the ordering of the extensions being executed. You can also declare extensions programmatically with register extension, and this can be helpful if you want to have a little bit more of a dynamic nature or reference fields within a test case or test class that might have some impact on the extension. If you wanted to have an ordering to extensions declared this way, you can add the @order annotation with the declaration of the extension and then provide the ordering they should be executed in, as is an example in this case. For parameterized tests, there's been some improvements here, namely that it's no longer declared with run with, so you can actually have both a parameterized test and then any number of other normal tests all located within the same test class. You can even have multiple parameterized test declarations within the same class. In this example, I am using a method source to supply data to this test, but there's also other options of, for example, value source, enum source. If you want to supply larger data sets, you can also do a CSV or even a CSV file source for maybe really large data sets you want to supply to a parameterized test. You can also do a repeated test, so if you just want to run a test case n number of times, you can do so with an @repeated test, and you can supply the number you want to have it be executed. When running a repeated test, the JUnit 5 container supplies the repetition info object onto the context, which can then be passed into the method of that test case, and that supplies information like the current repetition you're on and the total number of repetitions if you need that for the running of the test case. Dependency injection has seen some pretty significant improvements in JUnit 5. So here we have the repo field, and whereas in JUnit 4 only field injection was supported, in JUnit 5 constructor and also even method injection can be supported. So in the first test case, use class repo, then the class repo for the class is being used, and then for use local repo, the repo that's being passed into that method is being used in that case. So that can add a lot more flexibility to how you use dependency injection and a lot more clarity as to what a test case is trying to accomplish if you want to inject a dependency directly just within that test case. Finally, for just some kind of improvements on existing behavior, JUnit 5 offers significant improvements to conditional test execution. So in this example, I have a couple of test cases that are conditionally either enabled or disabled based upon the operating system. In this case, I have a test that's disabled if it's the test is being run on a Linux or Mac system, or also another test that's being enabled that's running on a Linux or Mac system. This is just as one example. The JUnit 5 team has provided a lot of the other options, for example, running this based upon what kind of JRE that the system is running, but you can also implement your own conditional behavior that kind of allows you to, however you want to have a test be run, or whatever condition you want to have it to be run, you can implement that behavior as you would like. So there is some gaps in JUnit 4 that were now not really easily able to be tested, that had kind of been filled in now with the release of JUnit 5. Two key ones is test ordering and also parallel test execution. So there's several options for creating ordered test, including you can also write your own implementation, but we'll just focus on the three that the JUnit 5 team has provided. Probably the one most developers and most people will be interested in is the order annotation method. And this allows you to declare an explicit ordering to test. In this example, I have two tests that are ordered, and these tests will be executed first and second. The other two tests will then be executed after these first two tests, so you don't have to order every test if you don't care about when it's ordered or when it's executed. You just want to have it executed sometime later. Also added, and I believe in JUnit 5.5, is you can also set a test to the max order limit if you want to have a test executed at the end of your test case. You can also do alphanumeric, which orders tests as its name by the alphanumeric value of the test case. And you can also do random. Random could be helpful if you want to test to make sure that there isn't any unexpected dependency between different test cases that should have no dependency. So by running them in a random order, you can then make sure that they're not being executed. There's no relationship. If you do find there is, for some reason, tests failing for a specific or within like a specific random run, a seed value will be printed out, and you can then supply that seed value into the JUnit Jupyter execution order random seed, and then that same execution order will be rerun as long as that seed is present in your Maven or Gradle file. Parallel test execution also solves actually just an outright inclusion in JUnit 5, and so you can enable it at the project level through your Maven file, and in this case a JUnit Jupyter config dynamic factor that will run tests or by the number of threads that will be available for running tests in parallel is based upon the number of cores on the system. So if you had 4 cores, it would run 4 tests in parallel. Concurrent also allows tests to run concurrently within the same thread. You can also further configure how tests will be executed through the execution annotation. So concurrent, again, will allow tests to run concurrently within the same thread, and then the same thread would be each test within the same thread runs serially within the same thread within that test class. You can further, if there's some sort of resource logging underlying some test, you can also add the resource log annotation to modify how those tests will be executed and when they can be executed in parallel. Read-write cannot be executed in parallel. Reads can be executed in parallel, but not at the same time as a read-write. So JUnit 5 also kind of allows you to be very creative with how you write the test with a couple of the new additions. Specifically, I want to talk about dynamic tests and then also test interfaces. So dynamic tests allow tests to be generated dynamically using the @testFactory annotation, and you put it on a method, and that method needs to return a collection stream or iterable of a dynamic test or dynamic container. And this can be really great for addressing cross-cutting concerns, like for example security, or here in this example I'll show in just a moment, for accepting different kinds of media types through your endpoints. So in this example, I have an API and it has a couple of endpoints, and those endpoints, these post endpoints, need to accept both JSON and XML. So initially my test only has 2 test executions, but if I uncomment this post mapping and then rerun the test, well, now I have 4 test executions, and then one of them failed. That one failed because that post mapping, as you can see in the declaration, is only accepting JSON, and really I want to have both JSON and XML being accepted in all my post mappings. So in my code for the test accepted media types, what I'm having is my code scan through my code base to see for every post mapping and then generate a test to check for XML and JSON acceptance for each of them. So this can be a great way that as your test or as your application grows, your automated test suite can automatically grow with it. You're not going to rely upon developers having to remember to write these tests for every time they add, for example, an endpoint, whether it's for, in this case, accepting media types or maybe doing some sort of security work. The other one is test interfaces. So in Java 8, the ability to write a default implementation for a method was added to a test to interfaces. So in JUnit 4 and Java 7 only 4, you could inherit from an abstract base class, and this could be good if you're maybe testing some sort of pattern and you want to just kind of supply some kind of initial constructs for a developer writing the test. But the problem with abstract tests is you have to then kind of implement our abstract classes. You kind of have to implement everything from that class. With interfaces, you can kind of selectively break apart some sort of pattern and then allow developers to implement whatever interfaces make sense for implementing or testing that pattern. So the example I have is using REST. An API may not be implementing all of REST every time. You may only be doing certain things like a GET or a GET and POST on some endpoints, but not necessarily maybe saying do both put and delete. And then also a REST API needs to follow a specific kind of pattern, saying like API, maybe the versioning number, and then the name of the resource. And then if you're going to look up a specific ID of that resource, well, then it should be /ID. Whether or not you want to follow REST doesn't really matter. This is just kind of an example of a broadly known pattern that can also be kind of implemented through test interfaces. So you can have a test interface, and in a default method, you can have a pre-constructed test that kind of then follows the expected pattern. And then within a test class that implements this interface, there's several different methods that then are interacted within the default method that the test class, the implementing test class, would implement. But where this is good is, as mentioned, like with REST, you wouldn't necessarily implement all of REST with every API, so you can selectively implement interfaces and break up the interfaces based upon different kind of behaviors of REST. So for example, I have the GET resource endpoint under one interface, searching endpoint under another interface, maybe handling posting, again, would be under a different interface. So a class can selectively implement all those different interfaces based upon what kind of behavior that API is supposed to be implementing. So I hope you enjoyed this test. I'll be around in the Q&A in the chat window, so definitely reach out if you have any questions. For the code I kind of showed off, you can go to my GitHub under Korando Welcome to JUnit 5 v2. I also put together a quick lab so you can actually put into practice a lot of what I talked about during this presentation, because I know I went through it pretty quickly, and so you can actually kind of get a little bit more hands-on, particularly some of the more difficult concepts like the dynamic test and test interfaces, which admittedly also took me a while to really get and understand. So once again, hope you enjoyed this presentation. If you have any more questions or you aren't able to get a hold of me in the chat, you can also DM me at Billy Korando on Twitter, or also email me at william.korando@ibm.com. Thank you for coming to my presentation.
That was awesome. Thank you so much, Billy. If anyone has any questions, like feel free, like you said, to put it either in the Q&A or in the chat.
Yep, thank you for hosting me, and yeah, thank you for everyone for attending. So we still have a few minutes. I just wanted to keep a few minutes here for any free-form Q&A. So definitely let me know if you have any questions. I'll be happy to answer them. So also, and I'll post this in here, I have written a lot about JUnit 5 as well. And so I kind of pared down a bit what was I've written about into this presentation. But if you go to my blog, pulling it up now, I do have quite a number of different articles that I've written about JUnit 5 that, again, also kind of go into detail about a lot of the different concepts I covered. Like I know particularly like dynamic tests and test interfaces. It's kind of hard to really fully cover them all in the space of like a few minutes because, like I kind of mentioned in my presentation, it took me quite a while to even really kind of fully understand them. But for actually, I think for both of those, I actually have entire blog articles that are dedicated to those two concepts. And that really kind of covers it in detail to kind of really explain what's going on in there. And then, of course, I have a bunch of other articles that kind of explain some of the new features that have come in JUnit 5, as well as kind of some of the evolution of JUnit 5, as I've covered, at least up to JUnit 5.5. It's currently on 5.7. All the new releases and like all the features that have come in them. So can also be a good place to check out to see more detail of some of the topics I covered.
And if there aren't any questions, maybe in the next minute, we can probably end a little early. You just covered everything so perfectly, Billy.
I'll take it as that there was no questions because all questions were answered. So
completely.
All right.
Anyway, thank you again so much. And then if you guys haven't filled out the survey, leave us some feedback just for future events.
Right.
Thank you guys. Thank you, Billy.
Thank you.
Bye. Have a good one.
Bye. Bye.